Okay. So last lecture we go with some of the parameter related with high performance computing. We learn about the how the central processing unit will be a work, arithmetic unit will be a work. What is the purpose of input output? Then we go with the multi-core architecture. So in multi-core architecture, we know that uh, uh, is concerned with that one. We know that we use the number of processor in a single or number of cores will be a usualized parameter of that things. That concept will be a clarify that one, right? Just a second. So a single processor which contain multiple core. So multi-core is possible with that parameter. We handle the number of instruction. Now the second parameter is related with that. We go with a multi-threading. That concept is very important point, and exam of point. It is very important concept related with that. So just look out the single thread process that which having a single thread that is called as a single instruction stream, and thread of execution, the multi-thread process. In that multiple thread will be available. So it carries a multiple instruction stream. So just clearing that concept, I will explain with parameter. Suppose we have a group of tasks. Suppose one unit will be having a number of instructions, right? So suppose the arithmetic and logical unit, that is ALU, which work on addition, then subtraction, division, and multiplication. So the ALU having four instructions, right? So addition also contain the number of addition. Addition number of one number, two number, three number, four number, five number is like that. So this addition contain the four to five instructions. So that will be divided into a means the main task is a addition. In that have a subtask. This subtask is nothing but we say that threading. That is a threading parameter. So addition. Suppose multi-threading concept that with the addition of this number. So this thread is related addition of two number. This thread is related of addition of three number. This thread is related with addition of four number. So it is a subtask of execution which are work simultaneously. So execution by one means first, then second, then third, rather than three instructions are executed at simultaneously. That is the concept of multi-threading. Or best example for multi-threading is a thread is a independent unit of execution creating within the context of process, or we say that application that being be executed. So when multi-threading are executed in a processor at the same time, we get the terms multi-threading. So, meaning of that multiple uh, instruction will be executed at the same time. So we say that it is a multi-threading concept related with that parameter, multi-threading parameter. So multi-threading is a model of program executed that allow for multiple threads to be created within a process, executing independently but concurrently sharing the process resources. Meaning of that, the addition of one number, two number, three number will be executed by same process, but they work simultaneously. They work the simultaneously. So the concept of multi-threading need to be a process understanding of two terms. One is a process and second is a thread. So process is a program being executed. A process can be further divided into a independent unit. So what the unit we learn about that one. So basically we understanding the concept of multi-threading parameter. Just I eliminate this. So we going with that one. So just look out that. Look out this one. Suppose we take one example for understanding the concept of multi-threading parameter, right? So consider your internet browser. At any given time, you can have numerous tabs open. We can open tab 1, tab 2, tab 3, tab 4. In a single browser, we use a multiple tab, and all tab have working. At it is always having a working parameter. So each one displaying the various type of content. The multiple threads of execution are used to be a load content, display the animations, play wide videos soon. Huh? Life cycle of threads. The following are the stages of the thread goes to be a, in the whole file. So what is the meaning of that? Suppose we use a browser, which browser having a multiple browser, browser 1, browser 2, browser 3, browser 4. For example point of view, just I given that one is like that. Suppose currently I am using this Zoom meeting. Same time, this browser also working, which having the WhatsApp, which having the inbox, whatever the mail, then whatever the other application. So multiple, uh, it will be a working the multiple. So it is a thread 1, thread 2, thread 3, thread 4, and your Zoom is also one of the thread related that one. So that concept is related with the threading parameter, right? So this is nothing but actual threading, a single processor which can be a work multiple instructions. So we say that this is a multi-threading concept parameter, right? Is it clear to everyone? What is a multi-threading parameter? Om, is it clear?
Yes, sir.
Yes. So just consider one concept. The life cycle of bronze thread. Bronze thread means new thread, right? Who is the Apo CPH 2387? Name of student. Okay. So the life cycle of bronze thread is that is new thread started in this state. It is a uh, remains in the state till a program store. Means suppose we consider with a browser. Suppose this browser I open that one and opening new browse here. Just look out. So this is a new thread or bronze thread. What is the here life cycle? Up to when it is a open. If I close this one, the life cycle of that thread will be a close. That will be a finish. That is a up to the program will be a execution. Still, it is life cycle will be a present. Otherwise, the life cycle will be a till it is ending with the that parameter, right? So that is called as a life cycle of that particular frame. Renewable. A thread become a renewable after it starts. It is considered to be a executing the task given to it, right? So how it is possible to renewable? Yes, it is possible. Just example that this browser I open with again new browser, sub browser. So new browser will be open. So their life cycle will be a start again. Same thing will be happen. Suppose this is a Gmail. Whatever thing I open is that one and it is closed. Suppose I close it and open it again. Just look out that. So it is again open. So the life cycle will be a start again. So it is a reusable parameter. Then waiting. While waiting the another thread to be a present a task. Right? Time waiting, runnable threads enter into the state or a specific time interval, and then transition back with the time interval, explaining or the event of the thread I was waiting for the occurs. So what is the meaning of multi-threading parameter? So multi-threading is nothing but a main program which will be divided into a sub-program or some instruction. Is like that we say that we designing one of the web page, right? So what we do, we divide the number of tasks. Web page designing, we designing the front end. In front end, we designing the some of the function. Suppose login function, some of suppose browsing of functions, some of the other function. So this small function designing is nothing but a threading which contain a single program and which have a multiple sub program, that is called as a multi-threading program, and it is a parameter of the related with the parallelism. That concept will be a clarify. So rather than going with that one, there are some of the types related with execute the parallel instructions. So uh, the computer architecture, it is the most important question, and examly 101% they ask about this question. Most of the paper, it is a repeated question. Computer architecture or the, suppose I just remove this one here. Flying taxonomy, then parallelism model, system and memory architecture. So the question will be asked about the any computer architecture, flying taxonomy, parallel model, system and memory architecture. So flying taxonomy is a classification scheme of computer, right? Architecture. The taxonomy is based on the number of instruction stream and data stream that can be a process simultaneously. Meaning of that, number of instruction and number of data which work simultaneously, that will be a considered in a flying taxonomy. The by computer architecture. These are the for the category is flying taxonomy. So what are the category? Just I given here. Just a second. Just second. So computer architecture which contain or flying taxonomy says that number of instruction and number of data will be executed simultaneously. So there are four type of flagship taxonomy. First is a single instruction, single data. Second is a single instruction, multiple data. Third is a multiple instruction, single data, that is MISD. And fourth is a multiple instruction. Just fourth here will be, yeah, multiple instruction, multiple data, right? So what they say that flying taxonomy, number of instruction and the data, the stream of instruction and data stream that can be processed simultaneously. A processor can be executed simultaneously. So just look out this one. Just I make visible. Just look out here. This will be a data set, data pool, and this will be a instruction pool. Means it contains the number of instruction and it contains the number of data. But type is a single instruction, single data. So processor only handle take one instruction and related with a single data, and it can be a process. So we say that it is a single instruction handled by this processor with a single data. That is nothing but a single instruction, single data. It is a one-to-one working. It is like a one-to-one working of the instruction. Second is a single instruction, multiple data. That is SIDT. So there is a only one instruction, but the data is a different. Suppose we take one example. Just second. Suppose we take one data, taking a pencil here, so you can understand better way. Suppose we making a addition of C is equal to A plus B. So here the value of A will be a store value of A and B will be a differ here. For a first time it is 1, for second time it is a 2, then it is a 3, is like so on. Same like here 4, 5, 6. So there will be n number of data will be a present of A and B. The instruction is only addition of two number. Addition of two number. So what will be a he take a single instruction that is addition. So first processor make addition of A and B. The value of A is 1 and 4. So he make the addition of 1 plus 4. Second will be a make addition of 2 plus 5. Second data. Third will be a make 3 plus whatever the 6. So are you understand? So only one instruction for all three processors to execute the addition. But data is a different for each one. Data is a different for each one. So what we that we get the result of all three data at a same time. At a same time with a same instruction. So that is called as a single instruction multiple data execution. So it is one of the parallelism process, right? I move here. Second thing is a multiple instruction single data, right? Only a single data, but multiple instruction will be a work on that one. So we consider that one. Just look out here. A data is the same. The value of A will be 1 and B will be suppose 2. I make change of color. It is a make as a red. And the instruction are either addition, first instruction, and second is a multiplication. Right? So addition will be done by this processor and multiplication will be done by this processor. So what will be done? The result of this one 1 plus 2 and here 1 into 2. Right? So what will be that? Data is the same. Data is a constant. It not be a same for the processor, this one also and this one. But number of instruction will be a here. Number of instruction will be done. So this also works simultaneously. So we say that this is a part of the parallelism. Right? Next, considering with the another way, just step back. Multiple instruction, multiple data. So it may be a possible the data which having a multiple parameter. Just I remove this one so you can understand better way. Oh no, it is clear, right? Suppose it have a multiple data. A and B having a multiple data. There is like a 1, 2, 3, 4, 5, 6 is like that. Here also 6, 7, 8, then 1, 2. So it have a multiple data, but it contain the multiple. So we say that this processor will be used the one value of A and B. This processor will be used the one value of A and B, and this processor will be used the one of the value. So suppose multiple instruction. This will be a done. This processor will be done the addition. This will be a done subtraction. This will be a done multiplication. This will be a done division. This will be a done logical operation or some so we say that increment or logical. So multiple instruction will be a possible. So in this way, we say that this is nothing but a best example for the multi or we say that a plagiarism. So these are the four types of your multiple instruction set. First is a single instruction, single data. Second is a single instruction, multiple data. third is a multiple instruction, single data, and last is a multiple instruction, multiple data. So these are the four types of your related with a parameter, and it is a very famous question in exam point of view. Most of the exam they ask about the same thing, the same question. So the computer architecture or Flaness taxonomy say that it have a four type: single instruction, single data, single instruction, multiple data, multiple instruction, single data, and multiple instruction, multiple data. So these are the some of the types of this one, and this most of the time this question will be asked in a exam point of view. So compared to this, there is a one calculation parameter in first unit, that is a communication cost in parallel mechanism. So we making the parallel communication related with that one. So what parameter will be a consider when we go with that things? So that parameter we have to consider. Just a second. Just I clarify this one. Right. So we go with that one, communication. So it is also one of the question most of the time, the communication cost in parallel mechanism. Whatever you use the parallel type of communication, so what is the costing? So first costing is the message passing cost in parallel computer. So what is the cost to pass the message, to pass the message related with a parameter? Just making this one clear. Window is not adjusting. Right? So communication cost for parallelism. So first is the message passing cost in a parallel computing. The time taken to communicate a message between two nodes in a network is a sum of the time to prepare a message from transmission and the time taken by the message to be a travels the network to the destination. So what is that? We sending a message one node to the other node. So the message passing cost is the time to both the process which contain between the two nodes in a network, that is the sum of the time to prepare a message from transmission and the time taken by the message to travel the network to the destination. So time required for preparation plus traveling, both parameters will be considered for the calculation of the message passing cost in a parallel computing. Next, startup time, that is called as a TS, small ts, t to the base s. The startup time is required to handle the message at the sending and receiving node. The before starting, we have to prepare the message, then we transmit the message. So the time required for startup time required for the to handle the message at the sending and receiving end, both went. So this include the header, trailer, error, correction, information. It contain all parameter. So we know that in CNS we learn about that we send the package with header right now with error control parameters, right? Trailer parameter which added into a packet and then we transmit the packet. So it requires both the parameters. So setup time will be required to create a message, and that is termed as a T to the base S. Second, peer hop time, per hop time, that is called as a T to the base H. After the message leaves node, it takes a time, amount of time or finite amount of time to reach the next node in the path. This time taken by the header of a message to travel between two direct connected nodes in the network is called as a per hop time. It is also known as a node latency. Per hop time means one node to the other node. Suppose we sending the packet with some of the header and it sending from one hop to the second node. So whatever the time required to reaching from one node to the other node, that time is called as a per hop time. One hop to the second hop, right? That is concept related with a per hop time, and it is written as a T to the base H. Next, per word transfer time. Per word transfer time, that is the T to the base W. If the channel bandwidth is R, suppose we consider the bandwidth is R word per second, then each word taken time. Let's concentrate. If the channel bandwidth is R word per second, then each word taken the time TW equal to 1 upon R. That is irrespective of your bandwidth to traverse the link. To traverse the links. So that is the per word transfer time. Next, state and forward routing. State and forward routing. Yes, I move here. So the total communication cost for a message of a size M, So just look out. R is the bandwidth, and the communication cost for a message. The message size is a small m words to traverse L or lambda. We say that communication link is T communication equal to TS plus in bracket MTW plus TH divided by L, or sometimes we written as a lambda also be. Somebody will be written radar. So in most of the platform, the TH is the small. It is we consider very small parameter, and above expression can be approximately T communication is equal to TS plus MLTW. So this way we calculate this parameter. Next is a packet routing. So we also calculate the packet routing time. So the packet routing breaks the message into a packet and pipeline, then through the network. Since the packet may be taken different path, each packet must carry the routing information, error checking, sequence and other related information. We know that if is sending the data through the packet, wireless transmission, so the path is not predefined. Each packet will be take his own path, right? So the total communication time for packet routing is T communication is equal to TS plus THL plus TWM. In this expression, the TH is very small, then TS and TW. For this reason, we can write as with a M is a larger. The size of the message will be a larger. Then T communication is calculated as TS plus TWM. So this way we calculate the communication cost. So this is one of the question. Most of the time, exam point they given the some value and calculate this one, right? So this is a related with the first unit. We learn last totally related with that one. Each and every parameter is like that. Introduction to parallel communication. Why need of parallelism? Then store program computer architecture. Then we learn general purpose cache based microprocessor architecture. Then we go with implicit parallelism, then pipeline concept, then multi-threading, vectorization, then related with the physical organization of parallel platform. Then we learn the superscalar architecture. Then we go with the multi-core architecture. Then we observe today multi-threading concept and communication cost in parallel mechanism. And lastly, we learn the computer architecture, or we say that flange taxonomy. So this is related with the first unit of your HPC. Is it clear to everyone?